Okay, so we should start because we're a bit late. Okay, so welcome everyone. This is the section after ontology and standards for industry. So please take your seat. So we have two speakers for the session. The first one is Stefano Borgo, and then we have David Lee, who is here. So he will present on site. So Stefano, please, you can start. I'm sorry, I don't know the title of your presentation.
Yes, let me show the slides.
But no, but wait a second, because now we have another problem.
We have another problem.
We're very sorry for from the local
do,
side.
do you have a projector?
I mean, if you have your machine, you can have a look at the slides remotely because you will share the screen, right?
Yes.
You HDMI or VG?
We have we don't have
VG.
Good. Okay. Okay, Stefano, now you are on the screen. There are many people in the room.
Hello, everybody.
Okay, Stefano, if you want, you can share the.
Okay, let's see. Okay. You should be able to see now, right?
Yes, we are. Please, stage is yours.
Okay, thank you. So it is a pleasure, of course, especially because I see so many people interested in upper ontology or top-level ontology or fundamental ontology. I don't know how many names are used today. My concerns are here about my perspective as an ontologist in standards. And I have to say, I'm not really into standards in the sense that even though I've been working for many years now in different initiatives, some of which ended up with official standards, I'm always the point of view of an outsider there, because my interest is not really in the process, I'm not really even in deciding the topic. I join these groups because I'm really interested in avoiding ontological naiveties, and I consider that to be a problem. And since ontology is complicated, so having somebody, one head more that look into those conceptualization and formalization is always helpful. So that's the reason why I'm into standards, more support than really work as somebody doing standardization. So let's start from the basics. Let me see where. So standard is essentially just a collection of statements which are like, let's say in mathematics, they are normative. You circumscribe a topic and you try to stick within that. You work with a series of assumptions, and unfortunately, most of the times they are not explicitly stated. In a sense, people, when they read a standard, they have to understand that there is something on which it relies, which is not explicitly stated most of the times. And then these things, this collection of normative statements are of interest, at least to the developers. So, of course, Elisa gave the general viewpoint, the strong commitment, the ideal situation. But I've seen cases where people want to have a standard just because they want, in a sense, set an area with their view. And so it's kind of, power relationship between communities. And so there is all of that because it's a large domain and with a lot of interest. The standard then is for a community, but the community is, in my experience, is never clearly stated. Essentially, it builds up. Everybody that says, I will follow the standard, will be part of the community for the standard. Where following a standard means explicitly stating I'm complying with the standard, even though not necessarily completely. So this is, let's say, what we have in our hand now. And it should be fairly easy to recognize that it is the idea of a standard is the result of two revolutions. The first is the Industrial Revolution, of course. In fact, they started being institutionalized when it was mature. The first bodies were at the beginning of the 20th century. And it's also a consequence of the French Revolution. I remind you that in 1791, there was the first committee for the units of a measure, and it was chaired by Lagrange. So we have a top international scientist that started this idea. In 1881, there was again in France the first international conference that started this development of, at this time now, international standards, again with a major scientist into it. This to say that when you develop standard, terminology is at the center. So you have to be careful, like whenever you develop a scientific theory, to state exactly what you use and how you're going to use it. This was so in the mind of people that even the term ISO is not an acronym. It is a name because they wanted people to use the same name independently of the language they were speaking. Compare this to the United Nations, for instance, where you are using acronym, and depending on the language, the acronym changes. The evolution of the standards, now I'm not going into this because I'm not really interested, but this tells you that glossary at a certain point came out and where started. I don't really know when this happens. I try to search a little bit, but I cannot pinpoint a specific period. But at a certain point, you start having glossary at the beginning of the standard in order to drive the right interpretation and to fix the meaning of the terms used there. And within this trend, as ontology started being considered. I remember years ago when somebody said, oh yeah, we are putting our hand in the standard, we now are ontologizing the glossary we have in it. And I was quite curious of what they meant by that, but that was the idea. So let's say the interest in ontology in building standard went through the problem of the terminology, which seems reasonable at least 20 years ago. But now that if you want to look at how the ontology impact the standard, I would distinguish 4 different ways. The first one is more on the linguistic side. It's where you start saying that because of the evolution of ontology and the push for developing knowledge representation languages and related tools, people moved the standards from previous languages, like I say, Express, and I talk about STEP, so very heavy, perhaps the largest ISO standard, into languages that allows you to take advantage of new technologies. And this step is important. It's not too hard, it's not trivial, but let's say it's something you would expect given the state of the art today, especially when you have these important large terminologies and normative statement with that. There is another step which is perhaps more interesting for formal ontologies, and it's when you try to reorganize the standard, in a sense, reorganizing the domain. You want to somehow get a conceptual clarity, and then you start seeing that some parts needs to be reworked in terms of the primitives or the basic concept that you rely upon. But you try to keep as much as you can as it was because you want to maintain some the possibility of people to keep using what has already been developed so far. So this is a kind of a trade-off situation where you understand that conceptually you can improve, but at the same time you have to comply with the domain that you built by the existence of the standards over the year. The last 2 points, I put them together. They are the most interesting. And they mainly happen when you have a standard based on ontology on a new domain. That's my experience, at least. And, so there you start working on a domain because you want to build a standard so that technologies can develop. But you don't comply exactly with what is done by experts in the domain. You want to somehow rethink of a better system of knowledge in ontological terms. This is done especially because of this interoperability problem that is on top of our head basically every day. Ontologically speaking, this means that there are many ontologies, even top-level ontologies or foundation ontologies, and they are not going to disappear. There is no convergence process. We have seen none in the last 20 years, so people accept now that there are different points of view, that they are relevant depending on what you want to do, and then they comply with that situation. But now you ask yourself, what is interoperability? The first question is, are number 2 and number 3 interoperable? So let me point out, that's a reasonable question. Number 2 and number 3 are entities. They are characterized by a series of relationships and properties. So it makes sense to say that they are interoperable. And the answer is, of course they are interoperable. They're all part of a number theory, in particular of the integers. And the theory has 2 and 3 inside and builds all the relationship in a coherent way. But then you start asking, is 2 and 2.0 interoperable? And here, the answer is not obviously yes, because 2 is part of integers and 2.0 is part of rational or reals or even complex, whatever you want to put there. They are different theories. Now you have to build a connection between the 2 theories in order to achieve interoperability. That means you can embed the integers into the reals, or you can work as a separate theories and then translate the result from one to the other. You choose, there are different ways to do it, but you have to work for that. So the first case, number 2, number 3, is more or less similar to what Elaher, the talk we had yesterday from the European Space Agency. They said, well, we build all the models. Of course, we do modularization, but we are in charge of all of them, so we make them compatible with each other. So it's like having a single theory and then building the elements that you need. So interoperability there is built in, as it is built in the integer theory. The problem is when you start building a theory or a model or a standard, and then you want it to be compatible with whatever is out there, which you have no control upon. This is the problem that people have. And some direct experience was in robotics, and they said, oh, yes, we have done this work here. We committed to that ontology, but you know, there are a lot of other people working in the domain that are using others. So we want to build something which goes beyond a strict commitment to a single ontology. The point there, it's quite interesting, is to say, I write explicitly the key concept I'm going to use. So for instance, I might use heavily the distinction between objects and events. So I state you have to have the distinction in order to use it. And then I use properties, but you know, maybe using properties are qualities or are dispositions or standard traditional attributes. It's not really relevant. And then I say, okay, you have to have some type of property in the ontology, but which one is not important. And then at that point, you build a kind of a reference ontology for your domain, which will be included in the standard, and then makes the standard acceptable in a sense, or I would say better, interpretable by each other top-level ontology that has the core distinction. Not necessarily even top-level ontologies, but any system that can cope with the key distinction. And this is, I believe, what we should look for. That makes a little, that raises a series of problems that only rarely I see discussed in standard bodies. I'm not going into standards for ontologies themselves, so the ISO 21838 or the different RDF, OWL, DOL standards in W3C, OMG, etc. That's not my concern here, but be aware that this is also a big chunk of development for ontology. So let's go to see why interoperability in the sense I was talking before has an impact, and we should be aware of it. So assume I'm working in a company and I received something we have ordered. I can say I received the resource 159, or I received the resource 159 for a certain production, because it was built in order to carry out that process, or I received the component 159, or I received the pump 159. So I am there, I'm kind of an interface between what happens in reality and the information system that I need to populate. And I have different ways to look at what happens. So in the first case, I'm looking at it as, I'm looking at something, describe it in terms of capacities. In the second one, I use the term resource, but with a different meaning because it's a role in a process. In the third one, I have a structural view of the objects, of what the object is for in a certain structure model, or well, anyway, in a structure of the product. And finally, I have a functional view. Now, the first question that you should ask, of course, is, am I talking about the same objects, or is it just the focus that changes? But the problem is that when I put the data in my system, I want it to be coherent no matter which choice you take to see what is this object. And again, in my experience, most people use the functional talk. And it is true, we could give priority to that point of view. But it is quite complicated. Functional language is highly complicated. So my suggestion would be actually try to make sense of all of them. Try at the same time to answer to was a Stefan Grimm talk yesterday. Say, yeah, but the ontology, it tends to overcomplicate the models. Yeah, we have to decide when the complication is necessary and when it is not. So let me give you an example here. Assume we take the functional perspective and then look at this model. This is from the literature, and I'm kind of abusing it. I'll tell you in a moment why. So it says essentially there is a thing, so that's the top of the ontology. This is written as an ontology, by the way. It's just the taxonomy, of course, here. And then it says there are different things I'm interested in because it is an ontology for a disassembly process. So I have different things to disassemble. So I care about the brand, the cost, this disassembly tool, drawing, mechanical product, functional part, fastener, market, even the recovery and disassemble strategy. Large top series of domains. And you build the ontology having this idea that it is for disassembly process. But then you end up making this choice that a screwdriver or a spanner, they are disassembly tools, which is not wrong, but as you know, it's not right either. And then you have this mix, let's say a turbine, which is our pump before, is a functional part, which tells you two things at the same time, right? It's structural information and function information. Now, it is fine. I mean, if you look at the paper and you look at this, the way they combine this with case-based reasoning and rule-based reasoning software that allows you to automatically do disassembly, it's okay. But the problem is that you will not be able to make this model interoperable with something else, something which is not specifically built for disassembly. And this is my problem. I agree with Stefan, I do not want to make the models overcomplicated because it's even harder to make them so sophisticated, so to add all the distinctions. But at the same time, I do not want to end up with a system like this where the model, the ontology, will not be useful outside that specific domain. I think we have to take this seriously, and I haven't seen initiative moving into that direction, unfortunately. So formal ontology has the capacity to integrate all these views. We have, as Elisa was saying this morning, we have actually a set of patterns that can help to do this. But due to the difference between the top-level ontologies and the variety of differences that you have in the point of view that the different stakeholders can bring into the system, when we talk about the industrial application, it is really complicated. So a trade-off between precise modeling and usability is a challenge. It's a challenge we have to take it, not to give up and say, oh, just take the functional talk. The other issue that as a foundation ontologist I want to take to bring to attention, I raised it a few months ago in an Onto Commons talk, and it was to suggest people not to ignore top-level ontologies. Take these three claims. The product was produced last week. The product is going to be customized this week. The product will be delivered next week. Now, every ontologist here understands right away what the problem is. And I wish the people working in the industry and the developing standards understand exactly what the problem is. The fact is that the terms product there refers to different things, and that is the challenge, how to model that. And the issue is not that people are not smart, they're very smart. The issue is that we use different principles when we talk about identity. And here there are 4 of them. There are actually 5 if you want to be complete. These are 4 of them. They come from the literature, it's work from the 80s, I believe. Late 80s. These are the one formalization of identity assumption we use in everyday talk. We have them. We could use them, but we don't. The reason is that they are incompatible. You use this in a system, it's trash, because these are inconsistent. That means that your natural understanding of these 3 expressions, they are based on using combination of these principles. They are going to, the problem is when you have identity across time. That's the major problem. So you in your mind, you make sense of this expression because every time you use a different combination of those principles. And this is the problem. So this is the problem that the foundation ontology has to solve because it's very careful in stating when an object exists, when it persists to exist, and when it changes. The person that is in the interface between what happens in the reality and your database, which maybe has only OWL at disposal, will not see those. And will not understand when it is modeling these 3 cases in one way or another one. So that's the problem that I have as a foundation ontologist when I work in standards. I have to be able to introduce something which is not complicated because people have to work with the standard, but that allows the data, because the human being is always able to read this stuff, but that allows the data that enter the system, the information system, to be consistent. And with this problem, I stop. I remind you that there is a committee in the International Association of Ontology and its applications, which is devoted to discuss ontologies in standard. I must admit that it has not been very active it is a recent committee. It was set up during the COVID era that we all hope is gone. But if you are interested in this kind of discussion, you want to, like me, join standardization initiative with the idea of helping them to avoid ontological naiveties, perhaps you would like to join and participate. And with this, I'm done. Thank you.
Thank you, Stefano. Thank you very much. Is there any question for Stefano from the audience? We have time for some discussion.
I can do some comments.
Yeah. So it's Mara Habel here. I don't know whether you can see the camera.
Hi.
Glad to see you again.
Nice to see you.
I am amazed how you can talk about my own ideas and thoughts in a conference. It's like look in a mirror. I totally agree with you. We complain about ontology making models complex, but the reality is complex. The word is complex. If the word was simple, we are using UML happily, which is not simple, but we are not able to do interoperability with them. And also using top ontology is not a religion, but is just the easy way of make clear what you are talking about. So if you have another way of doing that, we are doing another way. So very good talk, very good comments that you have, it shows that you have a lot of experience in doing that for real. So
Thank you, Mara. Unfortunately, I would like to have answers, but these are tough questions, of course. These are tough questions, and I agree with the comment that was today. People should not enter into the discussion. There was a point by Stefan Green yesterday as well. He said that it's hard to explain people the difference in the top level categories because they are too abstract, and not everybody needs to be trained in that way. So so there is a reason for having them. At the same time, there is a reason not to burden the regular people with those distinctions. And yes, so we still have to work to make these two realities to work together. Yes.
I disagree. I think that we should training people about this programming.
We should.
We should. We definitely should in the first year of computer science. Modeling is it's completely
Yeah,
different.
but would you do with engineers?
I am doing this for many years.
I've been teaching PhD classes to engineers for 6 years now, 7 years, different levels, civil engineers and mechanical engineers. And it is complicated. Abstract reasoning is not simple. And I understand why, but it's not simple. But these are PhD level. So if you do at the entry level, maybe it's you know, you started with the right basis. I have not, unfortunately, I don't have that experience.
Yeah, we should do that.
Okay, I think that we have another comment by Chris. Yeah? Okay, then go ahead. Go ahead. Stefano, if you can hear, if you cannot hear, just tell us.
Okay.
So, for standard, I have one question about the standard. Suppose we have a data model standard and we define a framework to ingest the data from all the stakeholders, and if the stakeholder coming from diverse background from government to small and medium scale industries or big corporate, how we are going to handle the real world data if even if the framework we defined is fully compliant with the standard, we can't manage the stakeholders. So if they are not following the standard,
Hello? Can you hear me?
not even an organization. So the data generated.
Sorry, I had there was a few seconds the connection stopped. And, so
Maybe if you
the sound is also.
then if you just want to come closer, maybe it's better.
Oh yes, please.
Yeah, just you're a bit late. I don't know whether it's on. This is the microphone,
Yes,
right?
you can put it
Okay.
here if you want.
Okay, just.
My question is like we are defining say data model standard, and the data ingestion will happen through several stakeholders for a given industry, and if the stakeholders are like coming from diverse background and we don't have control over stakeholders, then how we are going to manage the data coming from the different stakeholders if they are not following the standard defined rules. And in today's case, like even the data is not just coming from the organization, it may be coming through some automated machines like a deep learning model. Then definitely the data generated by a deep learning model is not going to follow the standard on which the platform is compliant to. How this kind of problem we can handle through like the mapping problem from the data ingestion side to the data platform.
Oh, that's a tough question. So let's say if you get data from stakeholders, assuming they do a coherent job, so their information is collected in a coherent way. That means that data might not comply with your standard, but it would comply with an ontology. So that's the step we have been requiring now for 30 years. Say, okay, do whatever you like, but indicate what is the ontology you are adopting, so that I can translate that ontology into the formal system used into the standard. That's, of course, it's not trivial, but can be done. If the data comes from machine learning, I'm afraid it's a big problem, because either you go through ontologizing the clusters that you come out with the algorithm, or more recently you go with hybrid algorithms that use ontology to actually build up the data they extract. So you are back again to the problem of having something which arrives somehow aligned with an ontology, which is what we are doing in the OntoCommons project. So whenever you come from a standard or not, as long as you are aligned to an ontology, we are developing ways to transfer data from one system to the other system, which is reliable to the point that the translation tells you they are. So it's not that there is not, most of the times it's not perfect, but at least you know how much you can trust. But if you don't come from something which is aligned to an ontology, well, then you go back to the older database techniques to integrate the data, and those are very limited. That's the reason why in the 80s it was the database community started moving to the different view that emerged as the ontological approach. So yes, I would say today the only answer is make sure that whoever gives you the data gives you also an ontology to make sense of it.
Okay, Stefano, thank you. Maybe a question, Chris?
Hi, ciao, Stefano. Can you hear me? Okay?
Yes, not very loud, but it's okay.
We can't hear you.
Yes, please.
Oh, Stefano, maybe you muted your microphone.
Oh,
Yeah,
no, I'm not muted.
at the same time.
Yeah, we cannot hear you.
Hello? No, I'm not muted.
Okay.
Okay, it was our problem. Okay.
Okay.
I like your talk, Stefano, and I like the history at the beginning. But now there's a point, a slide or two after that I just want to check on my understanding. So I liked you made a comment on that when you're aligning your data to an ontology, you've got two strategies, and I'm maybe misremembering here. One strategy is you don't change your data, but you just link it to the ontology. Another one is where you look at your data and you realize you have to change it so that it aligns more closely conceptually with the ontology. And I assume that your 2 and 2.0 thing is trying to make the point that these are two different formalization strategies, and you're going to end up with something that's not that might well not be interoperable. Did I understand your example well, or not? Am I putting my interpretation on your example, or?
So you're talking about the two strategies?
I think something we said that there was two ways of formalizing, and we see it. I think we see it quite a lot when people. Aligning to ontology means you just have to link upwards. You just have to say, I have this top level, I have the middle level. I just have to make links between the two, and I don't change my data, which is a common.
Oh, well, no, that's a different. Okay, I see your point. I think you have to ask David for this. He's much better than me. No, for the. Okay,
Well,
so
Stefano, because we can...
sorry. Can you hear me?
Yeah, now we can hear you.
Oh, sorry. So now, if you start separating the idea of data classification with data interpretation, then it gets much more complicated. And I don't have much to say there. I was saying that David, perhaps in the next talk, is going to tell us how to deal with the real data. If that is the question, Chris, I'm not really sure I understood correctly.
Okay, I'm sorry, we have to move to the next section. Thank you very much, Stefan.
Thank you.
Okay, so now we have David Lee from Caesar Corporate.
Caesar Systems, yes.
Okay, so
Your computer would object.
you think
This is read it anyway.
the USB should be interoperable?
Only for a problem one way up.
You never can be sure.
You never know. You can use this. You can use this. Okay. The one. Yeah. Does it move? No. Wait, because it was moving before. Okay.
Okay.
Okay, now it should move.
Okay. So just to remind people that the purpose of industrial data standards is to save people money. And initially, the key thing was to stop computer programmers arguing with each other over the interface between one CAD system and the interface of another. They would be poorly documented, and they would change over time. The computer programmers would argue, which cost people money. So you have an international standard which is stable and well documented. Other standards stop lawyers arguing with each other. If we've got a project saying data shall all be shared according to a standard, the standard is a defined document. It can be added to contracts, and it stops lawyers. So there to say,
It should come from here, the voice, right? Is there any problem with the audio? Talking with the ghost in the machine here. Because here the microphone it's open. Can you maybe help us?
yes, of course.
Okay. Stefano said that they can hear us, so it's fine. Yeah, because Stefano said yes, so it seems that they can hear us now, so it's okay. I'm sorry.
So we started with CAD because in some ways that was the biggest in the industrial side. That was the biggest cost benefit from computerization, getting rid of the cost. And then we moved from 2D drawings to 3D models. 3D models had the interface to simulation and engineering analysis, and it became more complicated. So we needed to move from card images to a data model. And we went
initial languages until they hit upon Express. And the initial work was extended. CAD was a good success, so it then extended to do kind of element analysis, and then CFD, kinematics, and then all the essentially the CAD people, the metadata around this, which and it is still, it is routine in industry, so it's a success.
Sorry, what? Now we lost the connection. I'm sorry.
Getting difficult.
Yeah, I'm sorry, David. It's now it's working. Now for you, it should also work.
But the early successes in some ways set us going down the wrong path for a lot of other things. The CAD was special, and that Express had this ability to be extremely precise about exactly what was populated and constraints on the data, so that you could validate an exchange file for geometry to say this is valid geometry. It might not be the product you is actually valid geometry. It will be loaded into a CAD system. There won't be any strange gaps. There won't be surfaces the wrong way around, all that sort of stuff. And so lots and lots of constraints are put in. And then it starts to fudge the distinction between actual things, like it's a surface, it has a bound, which is something which is ontological. With this, B-spline surface is a particular type of description. The same surface could be described ways. A cylinder could be a B-spline. It's a way of describing the surface. So the ontology and the description got all muddled together, and this is just making the point of something. It's quite simple here. A point, we know what a point is. We think it becomes quite an ontological problem about what a point is, but leave that on one side. What we've got is a whole lot of subtypes to do with how we represent a point, nothing to do with any of them being different. And if you went on the previous slide, it said that in defining the B-spline surface, the control points were to be Cartesian points. And why? Of the CAD systems available at the time the standard was drafted, nothing to do with reality. So this is where we are, and it's what we have to fix. The other problem is that there's lots of engineering knowledge hidden away into these descriptions. Years of legacy. This is a sort of fragment of bit of engineering data. It's sort of computer interpretable. Is it useful to the industry? No, not at all. It's behind the ISO paywall, and it's not findable using Google. And so it's well useless, in spite of the fact that there's been a lot of engineering work. That particular standard is 500 pages of detailed definition of data you need for simulation. And is it useful? Well, actually, people do buy the standard and they read it and they turn it by hand process into other formats, but they're then other proprietary formats. So it's a problem, and we need to get some stuff out there. And I started doing these slides or work on a UK government project on a national digital twin, and just scratching the surface of what the standards are. We've got all the ones we've been talking about, the STEP, which I've been talking, then geometry is CAD geometry. As soon as we've got digital metrology, it's measurements. STEP deals with design uncertainties, but then you've got measurement uncertainties, so we do it all over again. But the digital metrology needed a baseline saying, well, we've measured this, what did we measure? So they actually redo the standard for CAD geometry, which is actually different to the standard which is up here. So we have a mess. Of course, as soon as things get bigger, like process plants, we actually, and Landscape and how it opens to OpenGIS. So there's yet another geometry standard over here. Buildings, because they got a close link to STEP, their geometry standard was initially a subset of the STEP geometry standard, but because there's two standards committees, they gradually diverge. So there's a real problem here. One of the key things, which was at least interesting, somebody here from electrical, but both Mimosa CCOM and ISO 15926 were mentioned several times yesterday. These three standards, 15926 Part 2, Mimosa, and the EPRI SIM, it's not EPRI anymore, it's IC. They have standards to do with equipment out in the field. Where is it? How is it connected to other bits of equipment? What properties does it have as a element in the system? What system properties it has? And then you've got what of this piece of equipment is actually installed there and its properties and its maintenance history. And they all do it in much the same way. And as soon as you're interested in actually working electrical together with instrumentation, together with process, you have to deal with all of them, in spite of the fact that they deal with all of these things in much the same. They just not invented here. The terminologies don't align, but the concepts, they're basic engineering concepts, and the concepts do align quite well. Right, and I'll put this in. People put in too much. Indeed, that standard was mentioned yesterday too. It's a standard for maintenance, widely used. Do we want to write that ontology into a breakdown? Well, actually, some people use it for some of the time. When you show this to process engineers, often they laugh. And I say, well, it depends on the type of pump. Sometimes we break it down like this, sometimes we break it down like that. Those constraints, which says that when I've got a pump driver assembly, the driver is not considered as a part of the pump. That is a very specific constraint for a particular section of the industry. Therefore, we don't want to have it in at a high level. It is somewhere else. It's not part of the core ontology. So this is what we have to deal with. Yes. Yep. Number one reason. Reusing fragments of data models is difficult. With ontologies, it's great. With data models, it's a real pain. And ISO 10303 made an attempt to modularize data models, and it got more and more complicated. And I think the whole thing, I regard the whole thing as a modularizing data models just doesn't work. the point is that the data models do have these constraints in, and it's not just open world and closed world. That's part of it. It's a lot more about the completeness of data. And even things like, well, we're telling you the thing in these two ways. If you can process this information, please do, but we'll give you this information as well. The trivial thing will be an edge, which is the intersection of two surfaces. I can tell you the intersection of two surfaces, and if you're capable of generating what the edge is as they intersect, fine. But if you're not capable of doing that, I'll also tell you what the curve is. And the curve will sort of lie on the surfaces, but there'll be rounding errors. So, there's lots of detailed business stuff about how you use the data, and why would you want to put in an ontology? It works in the data models that we have in Express and UML, and if you don't bust, don't fix it. It's a question of doing what adds value. The other thing is, I started talking about magic strings, that it become more formal, but then we actually have, how do the magic strings get used properly? If they're references into an ontology, what subclasses in that ontology are appropriate for that location in the data model for it to be valid data. So we do start to need to look at the interaction between the traditional UML and Express data models and the ontologies. And I think for the next decade or so, that's actually going to be a very key aspect. And of course, there's reference data out there, and it's the sort of things which you want to point at. The ISO and IC has this common data dictionary with many thousands of items. It's very good, but they put constraints for implementation, and it's locked away inside a system. It has an API that isn't a view using a language which makes it so you can think of it as an ontology. That needs to be fixed. There are also other things. Again, 15926 part 4 was mentioned. Again, there are difficulties in terms of discipline. It becomes a bucket into what a lot of things are dumped. And one of the key discipline is looking how properties are that a pump has to have pressure ratings because it has fluids under pressure, and it has bearings, so it's a oil system and all that sort of stuff. And that can be shown via the tree. And sometimes this sort of intermediate level is either missed out or put in on fiat. There's no particular benefit for it, not on a linguistic purpose. If the thing down here is called a machine, they'll put machine up there without any real thinking. It's just done on the basis of the naming. So there needs to be more discipline in dealing with the reference data, and the reference data has to migrate to ontologies and gain that discipline through that migration. And it isn't just I put one lot up. There's vast numbers of standards. As soon as we get to digital twins, we get lots of stuff, and stuff is developed again and again. It's a bit on one side. And Internet of Things, ditto, but Internet of Things is even worse because we have competing standards. So in this world here, we have things like the garage door, which you can control from your mobile phone. But these people also have garage doors because one lot is looking at communications within the home and Bluetooth, and the other one's looking at telecommunications, and they're different standards committees, and they don't speak to each other. So yeah, right. This is essentially what I come here to sell. There is a group within TC 184 SC4 looking at core terminology for industrial data. And the process for developing the core for the IOF was identical to the process for developing this. It was the different sections were asked what were their core terms. They were all for different domains. In our case, it was different international standards, the people using different parts of STEP, the people from ISO IEC on the Common Data Dictionary, and indeed some people from, and we also have Evan Wallace from IOF involved who sits on this. So we have the communication there. All asked what the core terms were, and we assimilated them all. And right, what I'm going to do is go down to so we assimilated them all. We got some 59 terms, and the overlap between these terms and the core terminology proposed for IOF is vast, and it is, I think that it is a duty on us to solve this. This is currently out for ballot. There are a number of issues against it already, but the number one issue is it harmonized with the core terminology for IOF? And it's about the same size. The overlap of terms is about 70-80%. Back. Right, and then this diagram, versions of this diagram have come up again and again in this last couple of days. It's basically the Onto Commons diagram, and the IOF diagram merely leaves out other people's pyramids. It is essentially under BFO. 1596 Part 2 is more similar to EMMO than any of the other ontologies. It's similar, but also we have to work with existing legacy data models, and that is absolutely essential because the data models are out there, and they need the they need the reference data. And we're talking about this as a terminology because for the people down at the bottom, they're only interested in terminology. If you're asking people who design heat exchangers about the terms in their business, they're not actually, and I think and Lisa said this, and several people have said, they're not actually interested in the philosophy that goes on at the top. They know about heat exchangers, but they need to inherit from something that they understand, because it's not practical for the ontologists to go through the 100,000 items down here to check mistakes. You've got to give them a baseline which works, and therefore that so our phase one is to define the core glossary, and then there will be mappings. Well, if we harmonize with the IOF core, that's done, and then we have to look at the existing legacy standards and things like 15926 Part 2 and get the harmonization in there. Taken from our terminology one. The same diagram occurs again and again, and indeed it is usually a motor car because it's something, thank you very much, which it's something that everybody understands. It's a question of near side front wheel. Is it a type? It's not a type of component because you can't buy a near side front wheel. It's a type of assembly element. The term assembly element we invented actually because we looked around. There was nobody who had. There was no consistency. It started to be called a design occurrence, which sort of in some standards, but then we went to the standard for systems engineering, and systems engineering has system element, and we thought, right, well, this is also a system, but it's a system and it's a mechanical assembly, so we decided to go for some terms. But nailing these terms is quite important. We didn't want to use part because part, as far as I'm concerned, is a relationship. There's one international standard out there which defines the term part, and that gives an example of a part. A helicopter is a part. And I think, well, of what? So no. So So nailing the terminology is actually quite important. And so that was one. There is basically the metrology standard, because they also need to do metrology on assemblies, has exactly the same diagram with slightly different terms in bold. We have to nail it. We can't. It's our job. Yeah, kind of one. Yeah, so we start with all this. This is the moment. It's something which you intend to be part of an assembly. It's nailing this. It's nailing the terms and doing due diligence on the relationship to the terminology used elsewhere, and that's what we've been trying to do. And it's what we need to do, harmonize with the IOF core.
Sorry, what means deprecated? Because it used to be
Some people deprecated means some people use that word for this thing. Please don't.
Okay. Totally agree.
Yeah, assembly element again. We're trying to be precise about the terms, produce examples, and all that sort of thing. So that's one of the things which we're doing. We've got currently up for ballot. We need to do that. We need to do the alignment. And well, here I am. So that's what we're doing. That's done. So yeah, so that's what we're currently. That's one strand of taking things, getting ontologies into TC 184, IC4 standards. The other strand is a thing called the reference model for industrial data. It used to be called the future architecture, but again, it's come out for a new draft, and this is the high-level model of what we're trying to do. This model was actually drafted 15 years ago by Jerry Raddack from the Data Dictionary people, David Price from Top Quadrant, Alison Barnard-Feeney from NIST, and myself, and we drew this diagram up, and it has sort of survived several iterations, and it describes what you should do when creating an industrial data standard. And you start with the terminology, because if you don't know what you're talking about, that's fine. It's domain experts, and you start with the business activity model. If you don't have a scope, if you don't know why you're doing it, the whole thing is utterly pointless. The next phase, which has always been missed out, is to create an ontology, is actually to formalize the terminology so that we actually have a logical understanding of what the terms are. And the data models are not going to, you can stop there, of course, and implement the whole thing using OWL and RDF. But in practice, an awful lot of times you don't stop there. You actually need all the closed laws, not it. You need all the completeness constraints and all the implementation type constraints for a particular business usage. And what is envisaged is that something here in the ontology will correspond to entities in different data models. There will be different entities with different constraints about the data you record, but they will all be for the same thing. And if you want to interoperate different data models, you need to be precise in saying this entity is about the same thing in my model as as a different entity in your model. So the ontology is hopefully the basis for creating good data models, but a way of linking the two. And also, of course, because the data models have links to ontologies, as we've got subclasses in that pyramid, the kind goes down and down and down. If the entity has a slot saying, on what type of thing are we dealing with, we know what pyramid of subclasses we need to go for appropriate use in that data model. So working all these bits together looks like the way forward. And the data service model is reality. We've got a data model, yes, but these boxes with lines between. We need an open API or web service or something. And so there's going to be a data service model which actually implements an information sharing activity which you highlighted. It's the problem you're trying to solve. So we need to get all these boxes in place. Right, yeah, and this is what I see is that for a large extent, the data models will correspond to things here: a material object, a role. We use a word, assembly element. Role means different things so many times. This is why we need the terminology. And then there's a slot, goes to the appropriate domain. The data model knows what reference data is appropriate in this place. So yeah, so this is what we're doing. So the IF vision and indeed the Onto Commons vision, I think we can, it's pretty much established. It's just a question of making it happen. A plea, basically, there are 2 technical committees here. They were on the slides, the names of the technical committees. Be nominated as a national expert to sit on those committees. It doesn't cost anything. You just need to be nominated. The meetings are these days hybrid, and obviously we solicit people to come. But if you have an interest, you need to come. So there's 2 groups. There's the terminology group and there's the architecture group, and both need to be active. TC184SC4 now has a new chair from Boeing, who is extremely proactive and wanting to take these things forward, because Boeing knows everybody. There are people in Boeing who've given exactly the same presentation. They've been there. So one of the things we have to do is actually look at the existing standards and extract the data from them. There's hundreds, thousands of man years of engineering knowledge in there, which is essentially going to waste. And so that's one of the activities. It's starting a little bit, occasionally project, but if we can do it within ISO in a public way. A lot of projects do it. They mine express models to create stuff using newer technologies, but then it becomes part of a project. If they did the whole thing and published it as an ISO standard, it will then be out there and be reusable. This is a big problem. It is already established within ISO that terminologies are not behind the paywall. Because terminologies don't have shall in them. Terminologies are just there. And they're not really like other standards. And if we can get ontologies in the same bucket, so they don't go behind the firewall, if it is understood by ISO Central Secretariat, an ontology is just a super terminology. It's not behind the paywall. So that's a challenge. It's not where we are at the moment, but certainly the terminologies are. But if we can solve that, it will get us a long way. There's a lot of this being fair. If it's behind the ISO paywall, it's not fair. It's not accessible. It's not findable. So that's the next one. And my final one is what's some real challenges. Well, I've talked about this one. And so sometimes, if we can get the engineering data out there, we can simplify the models. Again, somebody yesterday said, well, ISO 15926 part 2 has too much in it. Quite so. We leave the core, the rest of it goes out as reference data and ontologies, and it's simple. Things we use words to make progress. So that's one. And structured data is something that for me with an analysis background is quite important. There are areas of our business where we have terabytes of data in arrays, and creating standard metadata for these terabytes of data. It might be CFD data, it might be remote sensing or whatever. That seems to be a problem. A lot of our existing standards, when they worked in Express, they teased everything away into sort of competitive entities, were inefficient, and if you do it into RDF, you do that.
Thank you very much. So, thank you very much for the talk. It was really interesting. Is there any question from the audience?
Aside from the fact that we're in violent agreement on a number of points, the OMG for translating most RDF, if your model is in UML or Express and is translatable to canonical XMI, then we can produce a starting point ontology for it. That standard is called most RDF. At least as opposed to just a paper drawing. Then you could perhaps use that data as the starting point for your development. The challenge there is that often the definitions and other notes and things are not actually in the model you're transforming. And then the other thing is that, of course, we transform things like endpoints on an association, which gives you a really messy ontology.
Yeah.
And you still have to clean it up. But if anybody's interested in tackling any of that, and if you have any ideas about how to get the models that are under the hood of any of these older standards, so that we could then translate them to current versions of UML and other things, then the opportunity to do the transformation becomes much larger. But a lot of people have those on their desktop, and they don't share. So they're published in the darn paper standard, but you don't have the model itself. You only have the paper.
Yep.
And that's a problem.
There is a question from Jim Logan, I think. Where is it? Yeah. He asks, if ontologies need to be free, then how might their creation be funded?
If it's into basically if it's standards, it's irrelevant. If ontologies are free, how is ISO funded? The people that develop standards have to get their own funding anyway. But standards, as I said, standards save money. If there isn't a company prepared to pay for the development of a standard, then it isn't very useful, because the objective of a standard is it saves that company money. And often it's a big company who want to deal with their contractors, and they will get a lot of pushback if they say, you will use our company procedures. If they can turn those company procedures into an international standard, and they say, you will use standard XYZ, I say, all right, we'll do that.
Yeah, Chris, do you want to add anything?
I guess David and I discussed this. I don't know if it was your breakfast this morning or last night. I think that's what David said is quite true, but there is another issue, is that if you get a standard, the other companies use it, so you create a level playing field. So there's actually a motivation to have any standard of any quality, because then you're all at the same level. So I'm not quite sure. I know what you're saying, Ed, but I think the truth is more complicated.
There's always stuff that people don't want to put in the standard, which is their business advantage. Yes, I agree.
We have a last question.
Yeah, I have a question about slide 22.
Okay, second.
Industrial standards. Industrial standards.
Okay, you can move. 21, 22.
Yeah.
Right. So I have the privilege of working in standards across many industries, and I'm just curious, are you aware of any reason why industrial tends to be a qualifier there? Could you just look that up?
Yes, because it's the title of the committee. And given that I complained earlier on about think Moses, CCOM, EPRI, SIM, and 15926 being different because they were different committees. Well, I've now done the same thing here. There's nothing special for industrial data standards here. It's the title of the committee. So actually, there might be all sorts of people doing this or better elsewhere, and I won't have met them.
Yeah, I mean, I find this compelling. I'm thinking I could apply it to agricultural production.
Yeah, yes. Yeah.
Okay, let's thank Daddy once again. Thank you very much. Okay, so by the way, people have been asking me for slides for of the presentation and so on. I don't know whether we plan to share the slides or if speakers can share the slides and then we
it's possible to put them on.
Can I share your slides? Yeah.
Yeah.
And Elisa, if you want, you can share the slides.
Well, we just have to
Yes.
PDF them.
Yeah.
Okay, that's
And also, I mean, all the sessions are recorded, so the videos will be online.
Okay, that's great.
Yes.
Okay, now I leave the floor.
Okay, perfect. So remove the table to install the panel.
Do you mind if I visit my laptop here?
All right, so we will build on our discussion this morning and the presentations in order to go deeply with standards. So in this panel, we have, so I invite to the floor, Sir, also Elisa, David, again, on the stage, and Jim. And online we have Michaela Magas. Hi, Michaela, do you hear us?
Yes, I can now. Yes, thank you.
Take a chair, sir. That's perfect. So thank you very much to attend this panel. And let's say one of the feedback that we had during all Onto Commons workshops. Okay. Perfect. So one of the feedbacks is to have standardization in two ways: is how to standardize ontologies and how to ontologize standards. So, and since this morning we are discussing a lot of points about standards and ontologies, and I prepared the first question about the relationship that can exist between standards and ontologies, and I think that during this morning sessions we discussed this point. But I will move to the second one directly, which is what is the degree of maturity of ontologies in standards. So let's start with Elisa.
Okay. So that's a big question, because if I look at ontologies I find in the bioportal or other places, the level of maturity of those ontologies varies greatly. So those that are developed for an academic project and then done are not very mature, many of them, even if they've been in the bioportal for a very long time. On the other hand, there are ontologies that are mandated for use in healthcare, for example, that have been around a long time and are relatively mature in some ways and not in others. So if you're using a standard, quote unquote, standard ontology that does not have sufficient metadata, sufficient provenance, sufficient traceability, and that sort of thing in just the metadata alone, then it's very hard to understand it. If you're a layperson, not an ontologist, hard to use it. And then from an ontologist perspective, if it's not well axiomatized, again, then you have questions about its level of maturity. There is work going on at the Enterprise Knowledge Graph Foundation. People are familiar with that, EKGF. You should look it up online, because what they're doing is a maturity model for ontology work specifically and for semantics and graphs. And so there is some work going on in that area that might be useful to help us predict. But for the work that I've done, we demand that the terminology and your sourcing of all your definitions is as good as the axiomatization, and both have to work together in order to have a standardizable ontology. Otherwise, on one side or the other is not sufficient.
Okay. So, David, from ISO perspective, what is the level of maturity? Working group, so
Yeah. Well, the thing, and that's being sort of, and it would be nice if it was thought of and as formal as an ontology. The real problem with reference data is the scale, because there's so much of it. And there also seems to be, with various reference data teams, there seems to be this macho thing. Our reference data library has more items than yours, and they get thousands of items. And you think, yes, but are they any good? Has anybody checked them? So there is this problem of managing the process. They need to be layered sufficiently, layered and divided by disciplines sufficiently that the review team is not given several thousand items to check, because it doesn't happen. And so what happens is that rubbish slips through. So there is a real problem, and I don't think it's a solved one, in the managing of reference data. And getting reference data into ontologies, in some ways, this makes the technical business of managing the data easier, but it doesn't make the people business any easier, and that is an ongoing issue. In some ways, the commercial companies are actually somewhat in advance. There's a system called E-Class from Austria for a lot of engineering data. It's extremely good, but that's not an international standard, and yeah, that's where we are.
That's perfect. So, Jim from OIG. So, what is the situation there? I mean, in terms of ontology and the degree of maturity, how you are dealing with that?
Yeah, good question. So at OAG, I mean, all of our ontology work is occurring within our organizational unit called IOF, or Industrial Ontologies Foundry. So it's been a long road. We have a beta out of our core ontology. Hopefully publish that core ontology as a final release here in the next couple months. We have a number of working groups working on domain ontologies, eager to publish their work based on core once they can. So yeah, that about sums it up for OAG. But if I could make just kind of one broader point, it's I kind of chuckled a little this morning when Elisa made reference to artifizing a standard. And I guess that would be the same thing as ontologizing a standard. And I think that the world is becoming more aware of ontologies, and it almost has a bit of a kind of a blockchain quality to it, it seems, where, blockchain was the answer for everything, and now ontology is kind of becoming fashionable again. And what I see is a number of organizations fearing that they won't retain the attention they have for their work. They're just slapping the word ontology on all sorts of stuff they have. And I think that it's going to be a bit of a marketing challenge for us to make sure that people appreciate what work is good and useful and what work is just relabeling existing digital resources.
That's perfect. So when you are mentioning this aspect, I would like to ask the question to CERN, because in NIST there is the attempt to ontologize step with onto step, which is a lot of years, and also there is another attempt to ontologize the standard IFC with IFCO. So I wrote a paper to criticize this with various means. But I mean, I would like to hear from you because a lot of attempts is to ontologize automatically. So, and I think, so I'd like to have your feedback on that, especially you are working with, in IWF core, so to get your perspective.
Yeah, so first disclaimer, I wasn't involved in any of those. Is that sufficient answer? So yeah, I obviously do not call those ontology either. So yeah, and I didn't know about that IFCO either. So that's why we are working on this IF ontology to make a real ontology and not just IOFizing the existing standards.
Yeah, so from practical point of view, if we would like to ontologize standard, what is the best way to do it?
You're asking me.
Yeah.
Okay.
He's looking at you anyway.
He is looking at me. Okay, so the first thing is establishing a set of criteria that you can use for measuring quality. And that criteria is somewhat objective. But for the work we've done on FIBO, the work we're doing with the IDMP pharmaceutical project, where there are a number of ISO standards that are coming together in the ontologies that we're building, a little bit of what we're doing for IOF in conjunction with OAGI, the real rubber meets the road when you can at least claim that you pass some level of criteria, that you meet a certain level of standard tests, and that you can continue to meet that over time and you don't diverge from it. And so the framework we're putting together for the IOF at the EDM Council is based on what we did over the years for FIBO because we needed it and it wasn't out there. So we run some 45 or 50 now, not all publicly available tests, Sparkle queries and other things to check for various issues in the ontology. Some of them are in a line with OOPS and FOOPS and whatever generation Assume is on now. We also have taken older tests from things like Chimera at Stanford and others, other kinds of testing frameworks like that, and then also from our own experience, what we knew, what we needed to do based on financial standards, which is, I'm sure you know, are really, really complicated. At the end of the day, in some ways as complicated as certain engineering models, in other ways just complicated very differently. Being able to run test data both over the public and private data has been essential. And you can't really standardize something until you have implementations inside of commercial businesses that are doing the work. And so, for example, for our counterparty model for FIBO, we had 5 million wholesale records at Wells Fargo that we pushed through the model to make sure it worked. We had a similar or larger activity going on at UBS, same at Credit Suisse. We've had people run tests over the model. They don't share their data with us, and obviously because of privacy reasons, a lot of it they can't share. But to make sure that it worked, to link together the issues in the ontology, to be able to find things that we didn't recognize, especially at scale, and to make sure that the model was useful otherwise. And without that, without testing commercially, I still think things are still immature. So, you know, I get that IOF has this core ontology that's getting better and better, and I've reviewed parts of it. But until it's aligned with some domain area, with some data that's publicly available, and with some data inside of Boeing or Airbus or somebody else that's participating in the project, I would tell you it's still immature. Until some large commercial entity can use that to solve some problem, it's still immature. And so I would welcome you to listen to Heiner's presentation later this afternoon to show how we're doing it in pharma, which is very agile, very aggressive, and yet we have those elements in place. Because I think that's a model that people could use for doing the same thing for other arenas like IOF.
Yeah. So let me ask a question to Michaela online. So Michaela, okay, that's perfect. You are discussing ontology, but as I mean, you are a founder of Industry Commons Foundation. So with your links with industry and so on, so is standards is the only way for ontology adoption, in industry?
Well, I mean, coming from the point of view of ontocommons, of course, and what ontologies can bring to industry, and actually zooming back and actually thinking of why are we doing all of this? We are doing all of this to actually help industry optimize and deliver better products and services. So really, from that perspective, if we look at what we can offer both the fixed points of reference through standardization, which the colleagues in industrial data and the colleagues in IOF are doing a very good job of. And of course, that provides a reliable system to reference. But also, there is another aspect which we should be running simultaneously, where ontologists can actually really contribute to the detection of mitigation of risks and detection of any novel events that are happening within the industrial ecosystem. And this is something we haven't been paying attention so far. So this is where ontologists can provide a phenomenal service from my point of view, especially when we look at it from the innovation perspective. So just to clarify what I mean by this. So basically, we have known in history, if you look at it from the point of view of enterprise integration, that there were instances when disruption has actually filtered right to the top and affected top level. And this is something where fixed systems can actually be severely uprooted when we don't have a system running in parallel that can monitor those. Where, for instance, we now really need both systems to work simultaneously, both a fixed and a dynamic, agile, more adaptable, expandable system, is in the instances now where we need to follow across domains. It is very much the ontocommons approach. The dynamic between beginning of life, middle of life, end of life of materials and products. This is now a major requirement from high-level policy. It's something where we have high levels of complexity, of course, because it extends enterprise integration, which, of course, as we all know, is already really difficult to agree within enterprise integration on the meaning between the different parts of enterprise integration. And if you look at the models shown this morning, all the models had mechanical elements, process elements, and business elements in the schema. And therefore, this already illustrated how complex these things are. But we are now going even further to ecosystemic integration, which brings additional levels of complexity. So both the fixed top reference model that, for instance, IOF is working on, or that industrial data are proposing, are relevant for this. But at the same time, meaning and relationships between meanings are dynamic and continuously evolving, and we need to mitigate the risks of the evolutions that we are not monitoring through fixed systems. So let's understand standards as agreed regulation, something that we have agreed in order to regulate industry, and they can be useful as a reliable agreed reference points for implementation. This is, for instance, where your designers of ventilation systems or things that were mentioned earlier will definitely need in order to be able to execute on their job. On the other hand, we have also seen some wonderful evolutions of visualization and collaborative tools for the creation of ontologies that, like, for instance, Ocean and some of the things that are currently evolving. We can definitely push this field further. This has been requested constantly in all of our workshops, both by professional ontologists and by industry. And if we allow for a dynamic creation of ontologies, what happens is, for instance, there is a danger of everything being fixed because we miss radical innovation instances that can ultimately uproot a standard. in the dynamical co-creation, in the dynamic co-creation environment of ontologies, if we allow these tools to be a co-creation tool for the evolution of meaning, they will show symptoms of emergence. And these can be, these usually happen before the actual disruption has occurred. And this is an incredibly useful tool for industry then to be able to monitor what is happening in the broader landscape of their ecosystemic integration, in their broader value networks. So you can actually pinpoint moments of potential disruption to existing relationships if we allow for a dynamic system to evolve simultaneously. And this is something that perhaps we should consider. If you look at, for example, IFC-OWL, there are some suggestions that it should be there should be a modular approach to the construction industry ontology. And there was a quote that I found which said it was a large monolithic ontology that presents serious limitations for real industrial applications in terms of usability and performance. Why? Because the construction industry is imminently going through a major radical transformation, and it's hugely risky for the incumbents. Now, this is because of top-level regulation that's happening from top-level policy. It needs to look at sustainable production, sustainable products, retrofitting, reuse, disposing of 98% of the plastics, for example, just to name but a few. This means it opens doors for disruptive innovation or radical innovation with technologies, which, unless it is monitored, the industry can actually face huge challenges in its transformation. So this is one, for instance, case in point where the dynamic model from ontologies can help to monitor the transformation in that industry.
Sorry, but Michaela, you're frozen.
Yes, I
hear
lost.
us?
We lost connection. Yes, for a while. Yeah, I can hear you now. So I don't know if obviously some part of the last bit was possibly lost there, but I was mentioning the IFC-OWL. I don't know if you heard that bit, and I was talking about the construction industry going through a transformation. So basically, this is where, for instance, a dynamic representation of what's happening or a modular approach to standardization there will actually help us transition that industry to the next stage that is required for the industry without the incumbents suffering major disruption or being basically where the disruption can filter to alter the relationships at the top.
So, before going to my last questions, I would like to open the panel for attendees if there is any question to our panelists. So please go ahead.
I would like to make a comment.
Yeah,
I am
please.
taking myself here. You know, I am from the tribe of Stefano Borgo and Varino and Barry Smith and so on. So I am one of the awful ontology that deals with meaning and ontology requirement. And sometimes we forget that when we build an ontology, we are not building something new. We are just putting a logical way what you are saying in your standard. So that's why an ontology should be free. Should be free because we are not indeed creating something. We are just making clear what you are putting in the standard. And that's a very interesting experience. I have done this with many standards, and it's amazing how we can be ambiguous and even contradictory in the definition in a standard when you put in a logical way. So that's the main contribution of ontology. What Michael is saying is more related to knowledge model to support tasks on industry and anticipate problems and so on. That's not really related to ontology. Ontology intends to clarify what you define in the standards and the relations and the vocabulary and so on. And this can bring a lot of insights for people that develop a standard. I think that a good formation in ontology makes production of a standard much more applicable and with less ambiguity and things like this.
Another
But I would
question?
say that logic
Yes,
that is,
Yeah, sort
you
of
know, logic, something that is logical for some people is not logical for others. I mean, relationships are defined in different ways according to different attitudes. So it is a bit difficult to say that there is one universal truth in terms of how logic works. I mean, we don't need to have a philosophical
There
discussion.
is hidden in some general definition of vocabulary. At least we know that we are disagreeing, not just hiding the disagreement. So,
Yeah. So I have a general question. As I work with a lot of different standards, trying to even get from the point of paper-based to model-based is first sort of transformational step by going to ontology. Has anybody ever thought about a pitch deck for standards organizations to be able to get them to understand the value of ontologies? A lot of times what comes up is, why do we want to put all this effort into it when the outcomes are kind of ambiguous as far as exactly what's the value that a standard, existing standard is already in use. Let's take, David, you were talking about like a QIF, for example. What is the value prop that we could give them to say, okay, if you ontologized your current information model or your paper-based standard, these are the additional values that you're going to get out of it, and this is what you're going to be able to do that you could not do now.
I have an answer.
Everybody
Yeah, we were working on 14224, and we actually built an ontology internally for the company for what they were doing. But then we went to the standards board, and we were trying to argue with them that their tables in the standard, they should produce an Excel spreadsheet for their tables. And it took 2.5 years, and we had to do it, and they were prepared to accept it. And I won't say anything about Norwegians here, but I will mention the guy in charge who was a Norwegian. It took 2.5 years to persuade them to produce an Excel spreadsheet.
Yeah. So yeah, go ahead.
And I can give you a similar story about other standards.
Oh, I know. I have many stories myself.
I have plenty of
They didn't have a slide deck, but you need to have a slide deck for Excel spreadsheets. When the guys have gone to Europe, you need to work out where they are on the chain.
Yeah.
I mean, given what you say that there's no added value. These existing data models work. The added value is the link to reference data. So that's just a delta on the standard, so that you know how to use for reference data, which is of high quality because it's been created using ontologies and a very precise way of referencing it. And that's a delta to the existing standard, which just makes it better. And that's, I think, I think it's the right thing to do at this stage. Ontologizing standards is I mentioned extracting knowledge and stuff. It's good, but it's a long-term researchy sort of thing. The benefits are longer term. What Michaela started mentioning some of the high-level regulatory things, and there are some things one thing which occurred to me, which is actually a failed project, which is the European Life Cycle Data Hub. You know, that if you want to, there was an idea about 20 years ago to start managing the environmental impact of products over their life cycle. And they set up a system for sharing that data. And it was based on XML files and XSLT transforms, and it was awful. And it's failed. And the need hasn't gone away, but actually we could do it much better now. So with in some cases there are some failed attempts at standardization and data sharing which we could return to if we can find somebody to if we can explain that we won't fail again.
Okay, so I have another perspective which you might anticipate. So I did a project, I want to say over 10 years ago, with a guy who was at the time at TIBCO and is now with Gartner. And that might tell you something on its own. But the project was to look at how you monetize the value of the ontology over and above the other models that you had in your environment and the other things that you were doing. So the challenge we had was figuring out where the ontology played a role that added monetary value. And what we figured out, based on what TIBCO's business model was at the time and what they were doing, was that if you used a logically consistent ontology, rather than people ad hoc entering vocabulary, as the basis for business rules, for rule engines, for driving business execution, you eliminated up to 80% of the error in the rules, because human beings can only keep about 100 rules in their head. And all of the vocabulary was all over the map, wasn't aligned. And, if people didn't see something, well, they'd add it. And if it wasn't in the language they knew, they would have to get it. So the bottom line there was, if you save 80% of the error in business rules, that's worth a lot of money. And so you have to find cases for whatever it is that you're doing. In engineering, I know we were talking a little bit about how you would use an ontology to drive certain things, and this goes back to the dynamic perspective, which is JPL is doing that. So if you have a logically consistent ontology driving your engineering systems, and you can validate your engineering models using that ontology and having a system in place that allows the ontology to evolve as your manufacturing systems evolve, then you can save a lot of money. And for JPL, it wasn't about money, although it is, but it was also about they get one shot. The rocket goes up. Maybe the rocket makes it into the orbit. Then you've got the satellite. The satellite might work or not. Then you've got the communications with the planet. Does that work? Then you've got the experiments that you're running on that satellite. And you add all of that stuff together and all of the engineering around it. If you cannot prove before you send the rocket up that it will all work through simulation, using ontologies to help prove correctness, then you're hosed. And billions of dollars are lost. So that's the other example.
Yeah, this is also the question online. So Tim Logan is asking, is there a collection of cases we can all reference where ambiguity has cost big money?
Well, you should ask, Jim, you should ask Nicholas Rouquette. He's your guy at JPL, and Steve Jenkins, who just retired, bless his heart, he was fabulous. So you should ask Nicholas Rouquette, but if you ask Nicholas, you have to have the time to listen to the answer. Just saying.
But this is a wonderful example Elisa has shown, and of course we agree to optimize. That is why we agree. So we optimize systems as soon as we agree. Now, what I'm advocating for is both the consensus and the fixed agreement to optimize. At the same time, not to lose sight of transformations, because industry is going through major transformations through data-driven systems and through the different rules of engagement that this engenders. And so what we need to do is also be able to map dynamically the relationships that are occurring in the transformation part. So there are different areas of application where agreement induces greater optimization, as Elisa has just quoted. But also, Elisa mentioned earlier patterns and how important patterns are. And identification of emergent patterns is an incredibly useful feature for industry, also to be able to manage transformations. So we should also look at this other perspective. And this one has been discussed a great deal before, can be actually approached from the point of view of visualization of patterns and patterns recognition as they evolve. So through interfaces that can allow our industrial partners to manage things better from that perspective. I would also add one other aspect, which is that we work a great deal in Industry Commons now on 4 different projects of registration of intellectual property and tracking and tracing intellectual property as it is created in parallel as another enabler in parallel to ontologies. Now, what we find is that a combination of dynamic visualization of ontologies by consensus, if you combine that with points of registration of intellectual property, you can actually pinpoint the moments of potential disruption a great deal more easily in existing relationships if you cross-reference. Now, this is a very exciting new possibility, which we never had before, and this possibly links to the idea that 20 years ago we did see the need for some of these systems, but we weren't ready. And now we have this series of enabling systems that are happening in parallel, that are being evolved, that can actually jointly cross-reference and actually create really interesting moments where we can pinpoint certain changes and transformations for the benefit of industry.
Thank you, Michaela. So we are running a little bit out of time, but I will conclude with a last question for all of you, all the panelists. So the question is about priorities. Priorities in short term and long term for this ontology standardization, the link between ontology and standards, and what initiatives and projects like OntoCommons IUF can do for that. So let's start with Sherm and then Jim.
To me, the priority is very pragmatic in terms of what I want to happen. So we started building ontologies, IOF core, supply chain reference ontologies, and the IOF core has been also, I guess, investigated by some of the STEP folks. I also have a project with the biopharmaceutical industry trying to extend the IOF core, and things are going pretty great. What they would like to see is the ability to actually specify localized terminology into the ontology. So I think creating some sort of like a scheme or infrastructure, um, to allow different groups of people even in the same organization, they would like to still use their jargon but be able to link to the standard ontology. So that seems to be very very important because you know even in the same companies you cannot drive people to use the same term. So but everybody recognize the importance of having a common ontology, common model. But again, they need to be able to use that terminology. They think that if they don't use their language, it's going to stifle their innovation. So that is a high priority for me. Um, yeah, I think that I'll give people opportunity to speak.
Yeah, so I think for me, so I'm kind of operating under the assumption that the IOF is well led with people like Will and Cern and Elisa running the show. But kind of for me at a higher level, and I'm glad I can answer Will's question at the same time. It is to create that pitch deck. If you look at OAGI's 2022 business plan, there are 3 deliverables. One is like a 2-page sell sheet on the relationship between ontologies and standards. Well, specifically OAGI's other standards, but what should be good for OAGI's standards should be good for UBL, UNC-FACT Core Component Library, and then branching out a little bit, QIF for quality standards, S-Series for integrated logistics support for aerospace, and the list goes on. So kind of a 2-page sell sheet, and then a white paper that goes into a little more detail, and then the pitch deck that we'll talk about. And so one of my major objectives in coming here this week is to just gather information. There's a lot going on. But
it seems like a great group of people. Oh, and one other thing is, I'm so glad that David has brought up a number of times and turned us into that, was about reference data. I'm really eager to understand how reference data figures into ontology development, because I see, especially in agriculture, there's enough discussion and arguments about what a standard where you put data. It's a whole nother iceberg when you talk about what does it mean. Now that I know where to put a few characters, what do those characters mean? And yeah, so I'm really excited by what Eddie's organized here and what I'm hearing this week.
Well, I think very much on priority is getting the cores. I mean, we have the IOF core, the TC184 core, and the Other Commons core, and we've got to come out the end with a core which is an engineer, what we call boil the ocean. So at least an engineering core is out there, which is understandable by the people developing the stuff underneath. The reference data, the domain engineers, they don't need to use what's above. They need to have something which is stable, which they can relate their data to. So that's the short term. The long term is that we do ultimately have to do the inferencing and the automated fault detection, both in failures of designs, which designs have millions of components, we rely on people to check that they all work together, but also in terms of real time. I remember, oh gosh, some time ago they were looking at automated detection of faults in electrical power distribution networks, and there was a man from EDF. I mean, it could have been from any of the established people would have said the same. He said, "Ah, yes, but our operators can do better than that." And the reply for the person who did the inferencing engine said, "But do they do better than that at 3 o'clock in the morning?"
Yeah, so I think that leads into exactly what my priorities are. So as an ontologist, what I care about is how do I test with real data whether the ontology works or not. And if I'm going to do that, how do I automate that testing that includes inference of various sorts? And who's going to build a new reasoning engine that actually can reason at scale? And reaching out to sort of the academic community, have you thought about that? Because for the IDMP project that Heiner will talk about this afternoon, we're ingesting millions and millions of records from a number of big ontologies like Kebi, or vocabularies anyway, like Kebi and other things, in order to map substances to one another. And then the databases at the pharma companies, and we're talking about, GSK and Johnson & Johnson and Novartis and Roche and really big companies with a lot of data. How do you inference over that? And there are some fast reasoners that are new out there. There are OWL-RL, not OWL-DL, but everything is done in memory. And there's no way that you're going to be able to achieve what you want to if you have to do it all in memory. And then you have things like Amazon Neptune that can scale, but they don't have the reasoning capability. And so how do you partition the data in order to do both? And I think that's a research challenge still. I don't think that's something the commercial community has dealt with. And for me, that's the big priority. That's what I would love to see people work on. So anybody that you have as a funding organization that wants to work on that challenge, I'd be happy to test it for them.
Thank you.
I think the data, what was the term using, was that kind of partitioning?
Yes.
I think it's kind of specific to the use case.
Maybe.
Yeah.
Maybe. In some cases it is. But in other cases, I think you have to bridge other multiple disciplinary data sets in order to really get the picture of what's going on. And if you're in a silo and you're doing reasoning over some specific use case, that doesn't tell you how it connects to the rest of the ecosystem.
Exactly.
Which is exactly right. I mean, that's where we have to go. We're not there.
Yeah.
Okay.
Yeah.
Because I feel the concluding remarks as patient and sustainability manager. So
well, as you well know, Hedy, OntoCommons started with a pluralistic approach for a very good reason, because approaches to what is logical or what is how things should be thought of were several, and therefore both in terms of creating practical applications that can optimize, that are fixed, that our colleagues here are doing, are incredibly useful. And we know exactly why they are being done and how they can be applied. And the other aspects which have been mentioned today, which are this: how do we negotiate? How do we monitor what's happening across domains? OntoCommons can definitely contribute to that discourse, and also with concrete examples of what we are detecting in our community, but also in terms of connecting this to other data reference points, including, for example, things that are coming from the whole area of transformation of industry. So we need to actually keep an eye on industrial transformation, because a lot of our assumptions are based on models. For instance, standardization was traditionally started in the mechanical era. We mustn't forget that. And you can see that, for instance, Etsy's approach is more to do with application protocols, really, in how they kind of approach standardization processes than the old mechanical concepts. So basically, we need to actually be able to, from our sort of pluralistic approach and cross-domain approach, to then also create systems, I would say visualization and interface systems that will allow us to monitor the industrial transformation and really service our industrial clients in that way.
Perfect. Thank you. So my priority now as organizer is to go to lunch. So thank you very much for all our panelists. Small announcement that, because we are late, so to have enough time for lunch and enjoy discussing. So all the sessions of the afternoon are postponed by 30 minutes.
What time is we should return?
At 2.
2.
Yeah.
Okay. And where we should go for lunch?
We'll guide you.
So I go to slides and then I will show the slides.
You'll have to say hi to Nicola for me.
Yes.